Hello there and welcome. I'm so glad you found your way here tonight. Maybe you had a long day, or maybe the quiet just felt a little too quiet and you needed something to fill it gently. Either way, you're in exactly the right place. There's nothing you need to do right now. No decisions to make, no places to be. Just rest here and let your body settle. Let your thoughts slow down into something softer. Because tonight, we're not going anywhere in a hurry. We're going to the ocean. Not the ocean you might picture on a summer afternoon, busy and bright with sunlight, but the ocean as it truly is, immense, ancient, and mostly unknown. We'll move gently from fact to fact, from the shallows to the crushing dark of the deepest trenches, from glowing waves on a moonlit shore to rivers running silently miles beneath the surface. Some of what you hear may surprise you. Some of it may feel like something you almost already knew, waiting quietly at the edge of thought. And before we begin, if these slow, calm explorations help you rest, consider liking and subscribing. It helps others find their way here too, one sleepy soul at a time. Now, close your eyes if you'd like, let your breathing slow, and let's begin. The ocean covers more than 70% of Earth's surface. When you picture our planet from space, what you're mostly seeing is water, not land, not cities or mountains or forests. Water. A vast, continuous body that wraps around every continent, connecting every shore. Most of what Earth is ocean. We live on the edges of it. And most of that ocean has never been seen. More than 80% of the world's oceans remain unexplored. More people have walked on the surface of the moon than have visited the deepest parts of the sea. The deep ocean is one of the last true frontiers on Earth, an immense space of dark water that science is only beginning to understand. The average depth of the ocean is around 3,600 meters. That's more than 2 miles straight down, and that's the average. In many places, it goes far deeper. The deepest point we know of is in the Mariana Trench in the Pacific. At its lowest, it reaches nearly 11,000 meters below the surface. If you placed Mount Everest at the bottom, its peak would still be more than a mile underwater. The pressure there is over 1,000 times the pressure at sea level. A human body would be crushed instantly, and yet life is there. Adapted, quiet, slow-moving life in the dark. The ocean contains about 97% of all the water on Earth, the fresh water we depend on, in rivers, lakes, glaciers, and underground, makes up only a tiny fraction of what exists. Most of Earth's water is salt water, ancient, deep, and old beyond measure. That saltiness comes from minerals dissolved over billions of years. Rain falls on land, picks up salts from rocks and soil, and carries them slowly into the sea. The water evaporates and returns as fresh rain. The salt stays behind. Over time, it accumulates. The ocean today is about 3.5% salt by weight. Every liter of seawater holds roughly 35 grams of dissolved minerals. This is why it tastes the way it does, and why you can't drink it. The salinity draws water out of your body rather than putting it in. The ocean produces more than half of the oxygen you breathe. Not forests, not jungles, the ocean. Tiny organisms called phytoplankton drift near the surface and photosynthesize, using sunlight to turn carbon dioxide into oxygen. Billions upon billions of them, invisible to the naked eye, exhaling quietly into the water and then into the air above. With every breath you take tonight, some of that oxygen came from the sea. The ocean also absorbs roughly 30% of all the carbon dioxide humans produce. It draws it in at the surface, dissolves it, and carries it into deeper water. It acts as a quiet buffer, slowing changes in the atmosphere. This absorption has a cost. The water becomes slightly more acidic over time. But for now, the ocean is still doing its work, still taking in what we give out, still balancing. The Pacific Ocean is larger than all of Earth's land combined. Take every continent, every island, every mountain range, and press them all flat. The Pacific would still cover more area. It stretches more than 12,000 miles from east to west. It is its own world, deep, wide, and barely mapped. Beneath the surface, the ocean has its own geography. Mountain ranges, plains, cliffs, and valleys. The mid-ocean ridges are the longest mountain chains on Earth. They run for more than 40,000 miles across the ocean floor, mostly unseen. Some peaks rise 3 kilometers above the surrounding plain, taller than any mountain in Europe, hidden beneath miles of water. There are valleys on the ocean floor deeper than the Grand Canyon, trenches that plunge far below the average seafloor into dark, narrow chasms where the Earth's crust folds downward. These subduction zones are where one tectonic plate slides beneath another, carrying ocean floor back into the mantle. New ocean floor is constantly being created at ridges, and old ocean floor is consumed at trenches. The seafloor is not permanent. It moves and renews itself over millions of years. The Atlantic Ocean is growing wider every year. At its center runs the Mid-Atlantic Ridge, where magma rises from below and pushes the seafloor outward. North America and Europe drift apart by roughly 2.5 centimeters annually. That's about the rate your fingernails grow. Slow, continuous, invisible. And the Pacific is shrinking. Its edges are being swallowed by subduction zones faster than new floor is created. Someday, in hundreds of millions of years, the Pacific may be gone entirely. The continents will rearrange themselves again, as they have before. The ocean doesn't stay still. It moves with the earth. Sound travels much faster in water than in air, about 4 times faster. And underwater, sound can travel enormous distances without losing much energy. There is a layer in the ocean, at a certain depth where temperature and pressure create just the right conditions, where sound becomes trapped and channeled across vast stretches of sea. This layer is called the SOFAR channel. A low-frequency sound made in this channel can travel thousands of miles, bending with the curvature of the Earth. Whales use this channel. Blue whales, fin whales, and others produce deep, low calls that travel through it for hundreds or even thousands of miles. A whale off the coast of one continent may be heard by another whale on the far side of an ocean. They are sending messages across distances that would take us weeks to cross by ship. We can detect these calls with sensitive instruments, but still don't fully understand what they mean. The blue whale is the largest animal ever known to have existed on Earth. It is larger than any dinosaur. Its heart alone is roughly the size of a small car and beats only about 5 or 6 times per minute at rest. Its tongue weighs as much as an elephant. When it calls, the sound can reach nearly 200 decibels, louder than a jet engine, yet pitched so low that human ears can barely detect it. Blue whales move through the ocean like slow, living mountains, gentle, quiet, and almost impossibly large. At the surface, on calm nights, whales sometimes rest in a behavior called logging. They float motionless with their blowholes just above the water, drifting like enormous logs. Half their brain sleeps while the other half stays alert enough to keep them breathing. They do not sink. They do not startle. They simply float, massive and still, rocking with the gentle motion of the sea. Sperm whales can dive to depths of over 3 kilometers. They can hold their breath for 90 minutes or more. In the dark, at crushing pressure, they hunt giant squid using clicks of sound, a kind of echolocation, finding prey in total darkness. Then they rise again, slowly, and breathe. Dolphins also sleep with half their brain at a time. One eye stays open. They continue to swim. They continue to breathe. Sleep for a dolphin is not the still, horizontal rest it is for us. It is something more integrated, woven into movement, into the rhythm of the sea. Sea otters hold hands while they sleep. They float on their backs at the surface and, in groups, reach out and grasp each other's paws. This keeps them from drifting apart in the current during the night. It is called a raft. A cluster of warm, floating animals holding on to one another in the dark water, sleeping together so they don't get lost. It is one of the quietest, softest behaviors in the animal kingdom. Seahorses are unusual in nearly every way. They are the only fish that swim upright. They are among the slowest fish in the sea, and the males carry the young. A female deposits her eggs into the male's pouch, and he carries them, nourishes them, and gives birth to dozens or even hundreds of tiny seahorses. Many species mate for life, greeting each other each morning with a brief, gentle dance. Jellyfish have existed for more than 500 million years. They were here before the dinosaurs, before the first trees, before fish had bones. They have no brain, no heart, no blood, no bones. They are made almost entirely of water, around 95%. Their bodies are transparent and silent. They drift with the currents rather than fighting them, pulsing gently forward. In some ways, they are the most alien creatures on our planet, and they have outlasted nearly everything. One species, Turritopsis dohrnii, the so-called immortal jellyfish, can revert to its juvenile state after reaching adulthood. When stressed or aged, it begins again. Not truly immortal, but cycling back to the beginning, over and over, in a quiet loop of return. The mantis shrimp can punch with the force of a bullet. Its strike is so fast it creates a cavitation bubble, a tiny pocket of vacuum that collapses and creates a shock wave, meaning it effectively hits its prey twice. But there is something quieter about the mantis shrimp that is perhaps more remarkable. It has 16 types of color receptors in its eyes. Humans have 3. The mantis shrimp can see colors and wavelengths of light that we have no words for. It perceives a version of the ocean entirely invisible to us. In the deepest parts of the sea, there is no light at all. Complete, absolute darkness. And yet, it is full of life. Creatures that make their own light. Bioluminescence is common in the deep ocean, far more common than on land. Anglerfish dangle glowing lures to attract prey. Lanternfish flicker in patterns. Squid flash and shift, communicating in light. Some creatures use bioluminescence to camouflage themselves, lighting their undersides to match the faint glow of the surface and disappear in the eyes of predators below. Light used not to be seen, but to vanish. Marine snow drifts constantly downward through the water column. It is not actual snow. It is a slow, continuous fall of tiny particles, dead plankton, fragments of organic matter, sinking gently from the surface toward the floor. It falls for weeks, sometimes months, before reaching the bottom. It is the primary food source for many deep-sea creatures. They live on what rains down from above, from a sunlit world they will never reach. Every night, something extraordinary happens in the ocean. Trillions of tiny creatures, plankton, small shrimp, lanternfish, and others, rise from the deep toward the surface to feed in darkness. Then, before dawn, they descend again, hundreds of meters down, every single night. This is the largest daily migration on Earth, happening continuously, invisibly, in every ocean, in every time zone. A vertical river of life rising and falling with the sun. The twilight zone lies between 200 and 1,000 meters below the surface. Light barely reaches it, just enough to detect, not enough to see by. Creatures there exist in a half-dark world. Many have enormous eyes to gather every last photon. Others are transparent. Some have no eyes at all. This zone is vast, one of the largest habitats on Earth by volume, and it absorbs more carbon than all the world's land forests combined. When creatures in the twilight zone die, their bodies sink with the carbon stored inside them, carrying it into the deep, locking it away for centuries. Beneath the twilight zone lies the midnight zone. No sunlight, perpetually cold, water temperature close to freezing, pressure that would collapse a submarine. And yet it is populated. Creatures move through it slowly and efficiently, hunting, feeding, waiting. They have adapted to a world with no sun, no seasons, and almost no warmth. At the very floor of the ocean, in the abyssal plains, sediment lies undisturbed for millions of years. These flat, cold, nearly featureless plains cover more of the Earth's surface than any other single landscape. They are some of the quietest places on the planet. Almost nothing disturbs them. The particles that settle there may have taken months to fall from the surface above, and on some of those plains, strange things grow. Nodules of manganese, iron, cobalt, and nickel form in perfect spheres over millions of years. 1 millimeter every 10,000 years, slowly accreting, layer by layer, out of the dark water around them. Billions of them, scattered across vast stretches of ocean floor. Silent geological clocks, ticking at a rate too slow for any human to watch. Some parts of the deep ocean floor are covered in bacterial mats, sheets of microorganisms living off chemical energy rather than sunlight. They thrive in cold seeps, where methane and hydrogen sulfide bubble up from below. Life here does not depend on the sun at all. It is chemosynthetic, drawing energy from the chemistry of the Earth itself. These ecosystems were discovered only in the last few decades. Before that, we did not know life could work this way. Hydrothermal vents are another world entirely, where tectonic plates pull apart, seawater seeps into the crust and is superheated by magma below. It rises back out as plumes of mineral-rich, scalding water, sometimes reaching 400 degrees Celsius. At that pressure, it doesn't boil. It simply rises, black with dissolved minerals that precipitate out and build towering chimneys around the vent. These are called black smokers, and around them, life crowds in. Tube worms 3 meters long, white crabs, shrimp without eyes, mussels and clams, dense, thriving communities powered entirely by the heat of the Earth. Life on Earth may have begun at a place like this. Before there was oxygen in the atmosphere, before there was sunlight reaching into the sea, deep, dark, hot chemical vents may have been the cradle of the first living chemistry on this planet. The ocean's oldest secret may be the origin of everything. Coral reefs cover less than 1% of the ocean floor, but support more than 25% of all known marine species. They are built from the skeletons of tiny animals, coral polyps, each no larger than a pencil tip. They secrete calcium carbonate, building structures around themselves over decades and centuries. Over thousands of years, those structures layer and grow, becoming complex, three-dimensional habitats. Reefs as large as cities, as intricate as any ecosystem on land. The Great Barrier Reef off Australia stretches for more than 2,000 kilometers. It is the largest living structure on Earth. It is made of billions of individual organisms, each one alive, feeding, and building. It is visible from space, and it is older than human civilization. Kelp forests grow in cold, clear coastal waters. Individual blades of kelp can reach 40 meters in height, rising from anchors on the ocean floor to the sunlit surface. They grow as fast as 60 centimeters in a single day. Within them, hundreds of species live: sea otters, rockfish, urchins, seals. The kelp moves in slow, continuous waves with the current. It is one of the most beautiful underwater landscapes on Earth. A cathedral made of light and green water. Seagrass meadows cover the shallow seafloor in many parts of the world. They are not seaweed. They are true plants. Flowering plants that returned to the ocean millions of years ago. They produce oxygen, trap sediment, and store carbon far more efficiently than most land forests. A square meter of seagrass meadow can produce about 10 liters of oxygen every day. Dugongs and sea turtles graze on them. Seahorses shelter within them. They are quiet, vital, and largely invisible to us. The ocean has its own rivers, not of salt water moving through fresh, but of water within water. Brine pools are found on the seafloor in certain regions. Pockets of water so salty it is denser than the surrounding sea. It sits in distinct pools, with its own shoreline and rippling surface. Fish that swim into a brine pool are stunned by the salinity. Crabs move along the edges carefully. These underwater lakes have their own currents, their own ripple patterns. They are one of the strangest landscapes on Earth. The ocean also has internal waves. Unlike the waves you see on the surface, these form at the boundaries between water layers of different density. Deep below, invisible, sometimes reaching heights of 100 meters. They move slowly across vast distances, breaking against underwater ridges and continental shelves, stirring the water and mixing nutrients without ever disturbing the surface above. Tides are a kind of breathing. Twice a day in most places, the ocean rises and falls. This is caused by the gravitational pull of the moon, and to a lesser extent, the sun, tugging on Earth's water. The water bulges slightly toward the moon, and as Earth rotates, that bulge moves around the planet. In open ocean, the rise is barely noticeable. But in enclosed bays and inlets, the water can be funneled and amplified. In the Bay of Fundy in Canada, the tidal range reaches 16 meters. The ocean floor is exposed for miles, then flooded again, twice each day, like clockwork, like breathing. At new moon and full moon, the sun and moon align, and their combined pull produces spring tides, higher highs and lower lows. When the moon is at a right angle to the sun, their forces partially cancel out and produce neap tides, smaller, gentler. The ocean listens to the sky. It has always listened. Tsunamis in the open ocean are barely noticeable. A ship crossing over one might feel nothing at all, just a slight, long swell passing beneath. The wave is there, but it is spread across hundreds of miles of open water, moving fast and nearly flat. It is only when it enters shallow water near a coast that it slows, compresses, and rises. The energy that was spread across the entire depth of the ocean gets concentrated near the shore. In the deep, it is quiet and invisible. The danger lives in the shallowing. Rogue waves were once dismissed as sailors' tales, enormous walls of water appearing from a calm sea without warning, ships lost without explanation. For a long time, scientists thought they were exaggerated. Then instruments began to confirm them. A 40-meter wave measured in the North Sea, oil platform sensors capturing readings that models could not explain. Rogue waves are real. They form when regular ocean waves overlap and reinforce each other. A confluence of energy that briefly produces something far larger than expected. Rare, unpredictable, and real. The ocean contains roughly 20 million tons of gold. Dissolved in seawater at incredibly low concentrations, gold is distributed throughout the ocean. There is also gold on the seafloor, in hydrothermal deposits. It is there. We simply have no way to extract it economically. The ocean holds treasure, and mostly keeps it. The seafloor holds more artifacts of human history than all of the world's museums combined. Ships lost over thousands of years. Cargo. Personal objects. The remains of civilizations that once stood at coastlines now submerged by rising seas. Some of these sites have never been seen. Many lie beyond the reach of current technology. The ocean is the world's greatest archive. The thermohaline circulation is a global system of ocean currents driven by differences in temperature and salinity. Cold, salty, dense water sinks near the poles and flows along the ocean floor toward the equator. Warmer, lighter water flows at the surface to replace it. This circulation connects all the world's oceans in a single, slow loop. The water currently on the surface of the North Atlantic may not return to the surface again for 1,000 years. It will sink, travel the bottom of the ocean, rise somewhere in the Pacific, and slowly make its way back. A 1,000-year journey. Continuous. Invisible. The ocean's own long memory. The Gulf Stream is part of this system. It carries warm water from the tropics northward along the coast of North America and across to Europe. Without it, northern Europe would be significantly colder. The ocean regulates climate not just for those living near the coast, but for entire continents far from any shoreline. The weather outside your window has been shaped, in part, by the motion of water on the far side of the world. Underwater caves and tunnels run through rock along many coastlines and beneath shallow seas. Some are flooded versions of caves that formed on land. Ancient passages carved by rivers when sea levels were lower, now submerged. The world's largest known underwater cave system is in Mexico. The Sac-Acton system stretches more than 340 kilometers through limestone beneath the Yucatan Peninsula. Inside it, archaeologists have found the bones of ancient animals and the remains of some of the earliest humans in the Americas. The sea covered these places after they were lived in. They have been quiet and dark ever since. Blue holes are circular sinkholes that open in the ocean floor or in shallow seabeds. They formed as caves during ice ages, when sea levels were lower and the land was above water. Over time, the ceilings collapsed or the sea rose and flooded them. From above, they appear as dark circles against the lighter, shallow water. They are filled with layered water, a thin, oxygenated layer near the top, and dense, stagnant, oxygen-free water below. Below a certain depth, it is a chemical world where almost nothing lives. Still, dark, patient. The ocean has a smell. that sharp, clean, slightly salty scent you notice at the beach. It comes partly from a compound called dimethyl sulfide, produced by microscopic marine algae when they break down. It is released into the air when waves crash and water evaporates. Seabirds use it to locate productive feeding areas from hundreds of miles away. The smell of the sea is not just a sensation. It is a chemical signal, ancient and information-rich, invisible and constant. In some coastal bays, on warm nights, the water glows. Bioluminescent plankton, dinoflagellates, light up when disturbed. Waves wash in glowing blue. A hand moved through the water leaves a trail of cold light. Schools of fish leave glowing contrails as they move. This light is a defense mechanism, startling predators or illuminating them for even larger predators above. But to a human standing at the shore on a dark night, it looks like something from a dream. A sea made of blue fire, quiet, liquid light. Greenland sharks live for more than 400 years. They grow slowly, less than a centimeter per year. They reach sexual maturity only around the age of 150. A Greenland shark alive today may have been born before the founding of the United States. They move through cold, dark northern waters with minimal effort, conserving energy across centuries. We know very little about them. They are some of the oldest animals on Earth, and they are mostly invisible to us, drifting slowly through the deep. There are fish in the deep sea with no eyes at all. In complete darkness, eyes are unnecessary. Over millions of years, many deep ocean species have lost them entirely. There are other senses, lateral line systems that detect movement and pressure in the water, sensitivity to electrical fields, and chemical reception, have intensified instead. The deep ocean is not just dark, it is alive with information carried in ways we can barely detect. The Dumbo octopus lives at extreme depths and is one of the deepest living octopuses we know of. It gets its name from the ear-like fins on either side of its head, which it uses to move through the water with a slow, gentle flapping. It has been found at depths of over 6,000 meters. In the crushing dark, it moves with grace. Translucent, soft-bodied, pale. A ghost drifting through a world of pressure and cold. The ocean floor spreads apart, but it also sinks. Where plates collide, one dips beneath the other in a subduction zone. As it descends, it carries water with it. Water trapped in rocks and minerals. At depth, pressure and heat release that water into the mantle. That water lowers the melting point of rock, triggering volcanism above. Many of the world's volcanoes, and many of its earthquakes, are born from the slow descent of ocean floor carrying water back into the earth. The ocean shapes geology from below. New islands are being created right now by underwater volcanoes. The Hawaiian island chain was formed by a hot spot in the mantle, a plume of heat rising through the crust and melting through it. The Pacific plate moves slowly over the hot spot, and a trail of islands marks where the hot spot has been. The big island of Hawaii is the youngest, still growing. Southeast of it, an underwater volcano called Loihi has been building for thousands of years and may eventually breach the surface. The ocean is still making new land. Ice covers the poles of the ocean's surface and affects the entire system. Icebergs calve from glaciers and drift southward, carrying fresh water from ancient glaciers. As they melt, they release it into the salt ocean, influencing salinity and density. They can travel for years. Some carry stones and soil scraped from land, which sink to the seafloor when the ice finally melts. Rocks from Antarctica have been found on the floor of the southern Atlantic, delivered by ice, released quietly, sinking alone. The Arctic Ocean is the shallowest of the world's oceans. and it is changing faster than any other part of the sea. Sea ice that once covered vast expanses year-round now retreats further each summer. Beneath it, life that depends on the ice is responding in ways we are still trying to understand. The Arctic is warming nearly 4 times faster than the global average. The ocean remembers, and what it remembers is beginning to shift. There are dead zones in the ocean, regions where oxygen levels have dropped so low that most marine life cannot survive. These hypoxic zones form where nutrients, often from agricultural runoff, trigger massive algae blooms. When the algae die, bacteria decompose them and consume the oxygen in the process. What remains is a near-lifeless patch of sea. There are more than 400 known dead zones worldwide. Some are natural and seasonal. Others are growing. The ocean is resilient, but it is not without limit. The sponge is one of the simplest animals in the sea, and one of the most effective. A sponge has no organs, no nervous system, no movement of its own. It draws water in through tiny pores and filters out bacteria and organic particles to eat. Some sponges can filter their own volume of water multiple times each day. They are among the oldest animal forms on Earth. There are sponge fossils from over 500 million years ago, and the deep ocean hosts some of the largest and longest-lived sponge specimens ever found. Some may be thousands of years old, living filters in the dark. The ocean is full of microorganisms that have never been classified. Every liter of seawater holds roughly 1 billion bacteria. Much of the microbial diversity in the ocean remains unknown. Scientists estimate that the ocean may hold 50 to 80% of all microbial life on Earth. These organisms drive the cycling of nutrients, the production of oxygen, and the decomposition of organic matter. They are the invisible engine of the ocean, and through the ocean, of the entire planet. At the very top of the water column, in the surface film less than 1 millimeter thick, a distinct community of organisms lives. This layer has its own chemistry, its own microbes, its own small insects and larvae. When the wind blows across it, tiny droplets are launched into the atmosphere, carrying bacteria and organic material into the clouds. Raindrops form around these particles. The ocean seeds the sky. The pressure at the surface is 1 atmosphere. For every 10 meters of depth, another atmosphere is added. At 1,000 meters, it is 100 atmospheres. At the bottom of the Mariana Trench, it is over 1,000. Creatures there have adapted at the molecular level. Their proteins and cell membranes work differently at such pressure. Life has found a way, as it always has, not by resisting the pressure, but by being shaped by it. The ocean absorbs heat as well as carbon dioxide. The top 2,000 meters of the ocean have absorbed more than 90% of the excess heat generated by human activity since industrialization. The ocean is warming, slowly and unevenly, but warming. Things are moving. Creatures that once lived in cooler waters are shifting poleward. The timing of migrations and breeding seasons is changing. The ocean is large enough to absorb an enormous amount of change, but it is not infinite. The sound of the ocean at depth is not silence. Even far below the reach of storms, the sea hums. Distant ships, breaking waves, biological noise. All of it blends into what researchers have called the ambient noise of the ocean. In some places, this background sound has increased significantly over the last century. Whales and other marine animals that rely on sound for communication are adapting, calling it different frequencies, different times. The ocean soundscape is changing, not loudly, but measurably. Stars have been used to navigate by sea for thousands of years. Ancient Polynesian sailors crossed thousands of miles of open ocean without instruments. reading stars, swells, bird behavior, and cloud patterns above islands below the horizon. The ocean and the sky were read together, understood together. For these navigators, the sea was not an obstacle. It was a landscape, one that could be read, memorized, and crossed. Some of the ocean's currents run for thousands of kilometers without interruption. The Antarctic Circumpolar Current runs all the way around Antarctica with nothing to stop it. No land, no barrier. It is the largest ocean current on Earth and connects the Atlantic, Pacific, and Indian Oceans. It plays a crucial role in regulating the climate of the entire planet, moving endlessly, turning slowly, connecting. Tidal bores occur where a rising tide is funneled into a narrowing estuary and the water builds into a visible wave traveling upstream. On the Amazon River, the tidal bore, called the pororoca, can reach heights of 4 meters and travel inland for hundreds of kilometers. The ocean pushing its way into the river, upstream, against the flow. At the boundary between salt and fresh, the tide makes itself known. Wave energy travels across entire ocean basins. A storm in the North Pacific can generate swells that travel more than 10,000 kilometers before breaking on the shores of New Zealand. The water itself doesn't travel that distance. The energy does, moving through water molecules that pass it forward across the ocean. A pulse, a transfer. The storm's energy arrives on a distant shore days after the storm has passed. The sea carries the memory of disturbance long after the wind has gone. The ocean holds heat at depth for centuries. Water that sank to the bottom of the Atlantic 500 years ago is still cold and dense, still moving slowly along the seafloor. It carries a chemical record of what the surface was like when it sank, its temperature, its salinity, its oxygen content. The deep ocean is a time capsule. By studying water at different depths, oceanographers can reconstruct centuries of climate history. The sea remembers everything. Coral polyps are animals, not plants. Each one is a tiny creature, soft-bodied, with a ring of tentacles that builds a hard limestone cup around itself. When a polyp dies, its skeleton remains. The next generation builds on top. Over hundreds and thousands of years, layer by layer, the reef rises, a living structure built from countless small deaths and smaller lives. Slow, deliberate, and lasting. Coral can bleach when water temperatures rise. When stressed, the coral expels the algae living in its tissue and turns white, bleached. This is not immediately fatal. If conditions improve, the algae can return and the coral can recover. But if the heat persists, the coral starves. Entire sections of reef have bleached and died in recent decades. And yet in other places, recovery is happening. Slowly, quietly. The reef has survived disruptions before. It is resilient, but it is tired. Sea cucumbers breathe through their rear ends. They draw water in and out of their bodies through their back passage to extract oxygen. They also expel their internal organs when threatened, sending a cloud of sticky threads and viscera at a predator, then quietly regrow them over weeks. They are ancient, simple creatures. They move slowly across the seafloor, consuming sediment, digesting what they can, and recycling what they cannot. The ocean floor would be very different without them. The ocean has its own electromagnetic field variations. Moving seawater, a conductor. Passing through Earth's magnetic field generates small electric currents. These currents create measurable magnetic signals that vary with the currents themselves. Scientists use these signals to track the movement of deep ocean water, Sharks and rays can detect electric fields in the water with special sensory organs, the ampullae of Lorenzini, and use them to find prey hiding beneath sand, and perhaps to navigate along the ocean's natural electromagnetic landscape. At night, the surface of the ocean is not still. Even in calm weather, it breathes. Long, slow swells move beneath the surface wind and carry the energy of storms from thousands of miles away. The sea is never truly at rest. Even when it looks flat and quiet and dark under the stars, it is moving. Beneath the reflection of the moon, the water is in constant, gentle motion. And somewhere in the deep, right now, marine snow is falling. Particles from the surface drifting down through the darkness, through the twilight zone, through the midnight zone, through the abyssal. It takes weeks to reach the floor, and when it does, it settles softly. A continuous, silent snowfall that has been happening every day since the ocean formed. Billions of years of snow, layer upon layer upon layer. The sediment on the ocean floor is the accumulated falling of all that time. The ocean has been here for nearly 4 billion years. It formed when Earth was young, from water carried by comets and asteroids, and from the slow outgassing of the planet's interior. It has seen the rise and fall of every civilization, every species, every ice age. It watched the first fish swim. It watched the first creatures crawl onto land. It will be here long after we are. Turning, breathing, remembering. It takes up most of our planet. It regulates our climate. It produces the oxygen we breathe. It feeds us, calms us, and contains more mystery than any other place on Earth. We have mapped the surface of Mars more carefully than we have mapped the ocean floor. We understand distant stars better than we understand the midnight zone of our own deep sea. The ocean is close, and the ocean is still unknown. And now, in this quiet moment, it is still turning. On the far side of the world, it is dawn somewhere over open water. Seabirds are rising from the surface. Somewhere in the deep, creatures are moving without light, without sound, without any knowledge of the world above them. And somewhere between the surface and the floor, marine snow is drifting down. Slow, patient, always. You are made of water. Not as much as a jellyfish, but enough. Enough that the ocean and you are not so different. Your body holds the same minerals that dissolve in seawater. Your blood is slightly saline. You breathe oxygen that once came from the sea. In some deep way that science confirms and the body already knows, you belong to it. You came from it. Everything did. So tonight, let the ocean hold you. Not literally, but in the way a thought can hold you. The thought of something vast and calm. Something moving in long, slow cycles. Something that has been here for 4 billion years and will be here long after everything you're worried about has stopped mattering. Let your breathing slow to something like a tide. In and out. Not fast, not urgent. Just the rhythm that has always been there. Beneath everything. The ocean doesn't rush. It just keeps moving. And you can rest now. Everything is still. If you happen to still be awake, you can go ahead and watch the next chapter now. I hope you sleep well. I hope you dream of open water and quiet depths. Good night.